Okay, so now that we understand what performance versus ability is, we can talk about what would happen if we got a big enough sample size or or enough performances so that we can really understand the ability. So if I am going to play golf and I hit the ball and I want to see how many times I can get a hole in one. I might get a hole in one out of 10,000 times. But if I were to look at infinite amount of attempts, maybe my ability is, 10%. So that brings us to the law of large numbers. So a performance can vary a lot when we're looking at a small number of attempts. If I roll a dice and I want to see how many times I get heads, roll a dice and get heads. No. If I roll a dice and I want to see how many times I can get a 1, I might get a 1, 0 out of 1 time for my first roll. Well, the next roll I might get a 1. So then I have 50% chance. So that kind of varies with that. So from here we can look at the definition. Okay, so the law of large numbers, as the more and more attempts that we get, the overall average performance will get closer and closer and closer to our actual ability. So the more shot attempts that we get, the closer I get to my true ability of what my actual shot attempt percentage is. So this brings me to this cool little thingy. Let's see how this goes. Okay, this is an applet that's going to show you kind of what I'm talking about. So if I look at 10 shots and I say that my ability, I'm going to move this up real quick so you can see, my ability to get a free throw is 80%. So that, I mean, again, I can't calculate it, but this is what I am giving you the percentage, is what I think the ability is 80%. Well, if I shoot 10 times, notice that the shot percentage is all over the place. It's not even close to 80% in 10 times. But if I change this to 100,000 and do shooting, look at how the graph is not working for me right now, but it should be getting closer and closer and closer to that 80. And if I were to keep adding, it actually would get closer and closer to that number. So I promise it's going to get really, really close to that line. But it doesn't look like it, does it? Fun. All right, so the more that we look at, so again, this is it's going up 71, 72, 73. As I add more and more and more, it's going to converge to what my true ability is. And this applet doesn't seem to be working in favor for us right now. But the more performances you add, the closer and closer and closer you get to the ability. All right, from here, I want to look at these two dot plots. And it says, which distribution shows 50 free throws and which one shows 200 free throws? Now, that's not to say that there's a 50 dots on one and 200 dots on one. Both dot plots have 100 dots. One dot on one of them represents a dot of 53 free throws, meaning here might represent that they made 65% in that one trial. And here represents that they made 84% in that one trial. So which one represents 50? Which one represents 200? Take a second, think about it. Which one do you think represents 200? Say it out loud. Just kidding, I don't actually intend for you to do that. But as we were saying, the law of large numbers, the more and the more and the more data that we add on, the closer and closer and closer that our data is going to converge to the ability. So notice on this right-hand side that these dots are getting closer and closer together. This one on the right represents 200 free throws because I have more data that's converging towards the actual ability. What do we think that ability is? Probably somewhere around here. Okay, the 50 free throws is more spread out. It ranges from like 60 to 95, whereas this one is from 68 to 84. So the more data that I look at, the 200 is going to be at a closer value than the data that's only 50 and is further away. That's the law of large numbers. It's my favorite thing in statistics.